Grade 6 Maths, Chapter 2, Commutative Properties and Associative Properties of Whole Numbers. Let us understand. Tell the number of adults at your home. For example, 3. I have 3 adults at my home. That is my mother, my father, and my elder sister. After this, let's count the number of children at your home. That is, for example, 2, 3, any. So if you add all the members such as number of adults plus number of children, or in the other way, number of children plus number of adults, both will sum up the same, that is total number of family members. So for example, you have 3 adults in your home and can be 3 children in your home. I add 3 plus 3 is equal to 6, as in 3 adult plus 3 children is equal to 6. So if I do it vice versa, that is 3 children plus 3 adults, that also comes to be 6 family members in total. So let's see another example down here. So if you see, there are 6 circles, right? So how do we count this? We have 2 rows and 3 columns. So 3 into 2 or 2 columns into 3 rows counts to be 6. So after that example, now let's start with our concept. So the concept says that in the above example, we got to know that changing the order of numbers does not change the sum or product respectively. Then this property of whole number is said to be commutative property. Let's understand commutative property with the help of Robonom. So the order of number in case of addition does not matter. Then Dirichlet says, does this hold good for all whole numbers, however large number they may be? Yes, it does not matter whether you add 3, 6, 5, 7, 8 to 5, 4, 6, 2, 9 or 5, 4, 6, 2, 9 to 3, 6, 5, 7, 8. The result will always remain the same. So according to this property, 2 numbers can be added in any order. Okay, and what is it called? This property is called a commutative property, wherein if you change the order of the numbers, the product or the result will not change. That will remain the same. Let's read the further conversation between Dirichlet and Robonom. It's great, but is it valid only for addition? No, it's true for multiplication also. The order of numbers can be changed when they are multiplied and the answer will remain the same. So in the above slides, we did some circles in rows and columns. So 3 into 2 or 2 into 3 remains the same. The answer remains the same, that is equal to 6. 3 into 2 is equal to 6 and 2 into 3 is equal to 6. So another question asked by Dirichlet. So both addition and multiplication obey commutative law. What about subtraction? Well, why don't you try it yourself? Robonom says, subtract 5 from 12. So 12 minus 5 is equal to 7. Good. Now subtract 12 from 5. But 12 is greater than 5. I cannot subtract them. That means 12 minus 5 is not same as 5 minus 12. So children, why don't you try? Okay, subtract 3 by 6. So you have to subtract 3 from 6. So 6 minus 3 is equal to 3. Now change the order. Now subtract 3 minus 6. What is the answer? Now 6 is greater, so you cannot subtract. So this rule does not apply. The commutative rule does not apply on subtraction. So Dirichlet says, yes, they are not same. This means we cannot subtract 2 numbers in any order. Thus, we can say that subtraction does not follow the commutative property. What about division? Why don't you check it yourself? So let's check for division also. Before moving further for division, let's revise our commutative property. Commutative property holds true for addition and multiplication. Let's multiply. So 3,456 multiplied by 452. The result is 1562112. Now reverse the order. 452 multiplied by 3456. So the result becomes 1562112. And both the answers are same. Now we will learn the subtraction and division, why they does not follow commutative property. So 18 minus 6 is equal to 12. Then what is 6 minus 18? We cannot subtract here. Why? Because 18 is greater than 6. So 18 minus 6 is not same as 6 minus 18. Hence, it does not follow the commutative rule. In the same way, do the sum to divide 24 by 4 and then divide 4 by 24. Check the responses here. So 24 divided by 4 is equal to 6, wherein 4 divided by 24 is not possible. Why? Because 24 is greater than 4. So we can say that 24 divided by 4 is not same as 4 divided by 24. Hence, for division also, commutative property does not follow the same rule. Likewise, in case of three quantities, we group the numbers anyhow to ease the calculation, but this does not really matter when numbers are grouped together for addition or multiplication. The answer remains the same. Such as for three quantities, say 18, 19, 21, let's consider 18 plus bracket open 9 plus bracket plus 21 bracket closed, which is equal to 18 plus 30 is equal to 48. Now bracket open 18 plus 9 bracket close plus 21. So we will first add 18 plus 9 and then plus 21, which is equal to 27 plus 21, which is equal to 48. Now the above example justifies associative property of whole numbers. Now consider the same three quantities given in previous slide, say 18, 9 and 21, and verify whether 18, 9, 21 mentioned property, that is associative properties, hold true for multiplication or not. Let's check the response. So the product from both the expressions is same, that is 3402. Hence, the associative property or law also is said to be same for the multiplication. So let's go through the conversation given in exploration zone about associative property on page number 28 and 29 in the concept book. So clonidac, we have seen that numbers can be swapped when two numbers are added or multiplied. What if there are more than two numbers? Do you mean to say statements like 12 plus 48 plus 24? Yes. In such case, we group numbers according to ease of calculation, but it does not really matter which number are grouped together for addition. So again, we will see the example here, that is 12 plus 8 plus 12 is equal to 22. And then we have another example. So one side we have 12 plus 8 plus 2, and on the other hand we have 12 plus 8 plus 2, wherein we will first add 12 plus 8 in the second expression and 8 plus 2 in the first expression. So 12 plus 10 is equal to 20 plus 2, which is equal to 22 is equal to 22. Okay, so it will not change the result. So clonidac's next question is, does this hold true for all whole numbers just as commutative property? Yes, this holds true for whole numbers. This property of whole number is called the associative property. So associative property of addition is, this property says that it doesn't matter how the number are grouped. when added, the answer will remain the same. In other words, we can say that in the addition of whole numbers, the sum does not change with the changing in the grouping. What about multiplication? Does it hold true for multiplication also? Yes. Let's look at the example below. 3 into 4 into 5, wherein first expression is equal to 3 into 4 into 5. In the first expression, we will first multiply 3 into 4, and in the second expression, we will multiply 4 into 5. So that will be 12 into 5 is equal to 3 into 20. Because 5 fours is 20 and 3 into 4 is 12. Then the total is 12 into 5 is equal to 60, and 3 into 20 is also 60. So associative property of multiplication, this property says that it doesn't matter how the numbers are grouped when multiplied. For example, from the three given numbers, it doesn't matter which two numbers are multiplied first. Thus, we can say that addition and multiplication are both associative. But I am wondering, what is the use of these properties? So Robonom says these properties are really helpful in doing our calculations easily. For example, it is easy to multiply smaller numbers like 2, 5 and 10. However, in case of large numbers, we can first make groups and then multiply easily. We apply the same in addition also. Clear, children? Example here, add 234 plus 166 plus 397. So here we can observe that adding 234, that is 234 to 166 results in 400, which when added to 397 makes the calculation little easier. Okay, so hence we can group it as per as the ease of calculation. Now Clonidac's next question is that both addition and multiplication are associative. But since subtraction and division do not follow the commutative property, can we assume that they do not follow the associative property also? So Robonom says yes, you are right. Both subtraction and division do not obey the associative property. So if we group as per the ease of calculation in subtraction and division, you will not get the same answer. Let's see the example here. So we have 534 minus 312 minus 124. So I have two expressions in the opposite sides. So in the first one, I have grouped 312 minus 124 first, and in the other expression 534 minus 312 first. So 534 minus 188 is not equal to 222 minus 124. 346 is the total for the first expression, wherein for the second expression it is 98. So the rule does not apply. The associative rule does not apply for your division and subtraction. Let's understand commutative and associative with the help of more examples. Choose the correct option and also fill in the blank. So you have some questions here, you have to choose the correct option, that which is this, that whether this expression is example of commutative or associative or both. And the second one is dash is an example of the associative property of addition. You have to check which expression here by calculating them. Check your responses here. So you can pause the video and check your responses, whether the answers and the calculation to your examples were correct or not. Let's quickly check what we have understood till now. Do this below activity, practice zone 3, page number 27 from the concept book. So let's see what is the activity. On a number line, multiply 6 and 2. Now multiply 2 and 6. Verify if the results are same. On a number line, add 12 and 3. Now add 3 and 12. Verify if results are same. Name the operations which obey and which do not obey the commutative law. So you can check your responses here And third answer was addition and multiplication obey commutative property, but subtraction and division do not obey commutative property. Let's do the assessment questions. Do question 4 and question 5 of checkpoint, page number 18 in your workbooks. You can check your responses here. Let's practice what we have learnt till now. So are my teachers ready? Teach your parents commutative property and associative property of whole numbers. Take any three currency notes or coins and ask them to apply the commutative property and associative property over addition on them and verify the two properties. I do. So this is an activity which you have to do. Take any three pulses in different quantities and verify the commutative property and associative property over addition and multiplication by making different combinations and pasting them on a chart paper. So you have to take three types of different pulses and you can show and verify the commutative property by making some expressions and combination and pasting them on the chart paper. So you have to paste the combinations made by pulses. Let's practice with the help of a worksheet. Do the practice zone 4 given on page number 29 of your concept book. What skills did we develop? Computation skill, comprehension and reasoning skill. So that was all about commutative and associative property. We will meet in the next session. Thank you. Stay safe, stay healthy, keep learning.